Good morning, grade 4s, and welcome to our next lesson on solids, liquids, and gases. Hopefully, going to be joined by my assistant soon. Oh, look, there she is, dressed in her cat outfit today. Yeah, all right, looking a little bit different to our unicorn. Right, so what we were looking at in our last video, we were looking at solids, liquids, and gases. Okay, and can you remember some of the properties of a solid? For example, over here with my ice. What are some of the properties of a solid?
You can't change it.
Yeah, you can't change the shape very easily. Yeah, all right. And does it take the shape of the container that it's in?
No.
It doesn't, and it doesn't take up the whole container, does it? Okay, so let's put that back in there.
And it's a fixed shape.
It is a fixed shape. Okay, so we were looking at the properties of solids, liquids, and gases. Today, we're going to be looking at how adding heat or taking away heat can lead to a change of state in a solid, liquid, or a gas. Okay, so the first one to look at now is how by adding heat to matter, we can change the state of a solid, liquid, and gas. And I've got two examples of here. So we've got our two examples of a solid here. I've got my ice block, yeah, okay, and I've got my bit of butter over here, which we can see, yeah, as it exists at the moment, is a solid. All right, firstly, because if I try and change the shape of it, it doesn't change shape very easily, does it? Yeah, and it's not going to take the shape of a container if I put it in. It's going to stay the same shape, yeah, and it's not going to take up the whole container. Okay, but I know that if I had to add heat to this butter, what would start happening to it?
It would melt.
It would melt. The same now if I had to start adding heat, yeah, to these blocks of ice. If I had to hold them like this, yeah, hold them there, press them really close together like that, what do you notice is starting to happen there?
It's also starting to melt.
It's also starting to melt because we're adding heat to that solid. Okay, right? So we now know that if we add heat to a solid, all right, what did we say starts to happen? There is melting taking place. Okay, and eventually that solid, just like that ice block and that butter there, is going to turn into a liquid. Okay, but it doesn't stop there. All right, because if we carry on adding heat, all right, to a liquid, it's also going to change shape. Now, we'll refer to the example here of these ice cubes. We know, that if we hold these long enough, they're going to melt. All right, and I'm actually going to give you guys a bit of a challenge later on to see. Yeah, you guys can do this at home. You guys can actually see how long does it take. You can time yourself. How long does it take you, or someone else? You can challenge each other, have a bit of a race. How long does it actually take you to melt one whole small little block of ice? All right. I don't know about you, but I can't hold that for very long. All right. But we know eventually what's going to happen to these ice is it's going to turn into
water.
It's going to turn into water. It's going to turn into a liquid, isn't it? But what happens now if I add heat to this liquid? What do you think is going to happen? Is it going to stay a liquid?
I don't know.
Well, let's find out, okay? And the easiest way to do that, and I'm sure all of you guys have this in your homes, right, is a kettle, fill it with water, okay, just like it would be with the ice, and we're going to add heat to it now, okay? So I put my kettle on, right, and now we know that we're adding heat to it because we've got the element at the bottom over there, and this water is going to start to what?
It's going to start heating up.
It's going to start heating up. In other words, it's going to start to boil, okay? And we know that once it starts adding heat, what do we think is going to start appearing out at the top of this kettle?
Steam.
Steam, okay, right? And what state of matter do you think is steam? Is it a solid, a liquid, or a gas?
Gas.
It's a gas. And how do we know it's a gas? Well, first of all, is the steam, going to stay in one place?
No.
No, it's going to move around this whole room, isn't it? Right? So it's not going to take the place of a container, all right? We know that because the gas is moving everywhere, the molecules that it's made up are not very compacted, very close together. They're everywhere, all right? And they will move freely, all right, around the room. Okay, and as I say, you might can't see it on a video there, but can you see the steam coming out of that?
Yeah.
Yeah, okay. So once again, all right, when you've added heat to a liquid, all right, it becomes a gas, all right? Okay, now my question is, all right, And the same thing, you can see this outside. If I had to move, if I had to put this ice over here, all right, outside, eventually it would become a puddle of water, wouldn't it? Okay. And if I left that puddle of water, all right, outside, and we left it there for a while, and you came back, would that puddle of water still be there? What do you reckon? Would it still be there, or would it have disappeared?
Maybe it could have turned into gas.
So in other words, would we be able to see the patch of water there anymore?
No.
We wouldn't. But does that mean that water has disappeared?
No.
It hasn't disappeared. It's turned into a gas. All right? And we call that process of a liquid, just like the boiling water, just like the ice over there, changing from a liquid to a gas, we call it evaporation. Okay? That puddle of water from our ice blocks, which turned into a puddle of water, hasn't disappeared. The water has not disappeared. It's turned into a gas, right? And it's gone up into the atmosphere. The same with our boiling kettle over here, all right? A lot of that water over there, now that it's boiled, all right, is starting to evaporate. It's turned into a gas, in this case steam, and it is moving up into the air, all right? So we call that evaporation. But now my question is, all right, what do you think happens now with that steam, and with that water, as it starts to go up into the air, all right, and the higher and higher it gets, what do you start things to happen, right, to the temperature of that gas? Does it start to get hotter, or do you think it starts to get cooler?
I think it starts to get cooler.
It does start to cool, right? And now, this is where we start to move on to this part here, where we look at what happens, all right, when matter starts to cool, okay? Now, what you can do is, you can do this at home with yourself, is you can take your kettle, all right, you can boil it up again, so that we can see the steam rising up, and then what you need is, you need just yourself a small mirror like that, okay? And what you can do is, take the mirror and hold it just above the kettle there, all right? And you'll still let the steam start to collecting on there, all right? If you leave it there just for a little bit, not too long, just be careful as well that you don't burn yourself, because steam can be very dangerous, so you might want to ask an adult to help you there, and you'll notice that I'm doing it and not her, all right? Remove my kettle away there quickly. What do you notice has appeared on the mirror there? What do you notice? Is it still steam, or is it now something else?
It's water.
In other words, it's a
liquid.
Wow, so that steam has gone from a gas to a liquid, and you can actually see the water droplets on there. Well, hang on a second. How's that happened? How's that happened? Well, it's actually very interesting, okay? That gas has now been cooled because it's gone from, right, where it was really, really hot coming out of the kettle there, right, onto the surface of this mirror, right, which was a lot cooler. So when the gas landed on this surface over here, and it was very cool, all right, that gas started to cool and it turned into a liquid. Now you can do the same thing, all right, really, really simply by doing something like this. You have a gas inside your lungs, air, all right, and when you breathe that air out, it's going from a place inside your lungs here, which is quite warm, to the surface of this mirror, which is colder. So if you breathe onto this mirror, okay, you'll notice, right, try and breathe a little bit like this. Have a go. And again, what do you notice has come onto that mirror over there?
It's water.
Again, it's water vapor, okay? So that gas that was inside your lungs, that air, has gone from being a gas to a liquid, okay? Now, it's gotten colder, all right? So we say that process of change is called condensing, okay? Condensing. That gas has condensed and changed into a liquid, okay? All right? And now, all right, that liquid, if we carry on cooling it, it's going to change as well. So we know, all right, that if we took that liquid, all right, and we poured it into a glass container like this, and we took this liquid and we put it someplace really, really cold, like the freezer, yeah, what do we think would happen to that liquid? What do you think, what solid do you think it would change into?
Ice.
It would change into an ice block, wouldn't it? So that liquid, if it carried on cooling, would then become a solid. Yeah, just like those blocks of ice if you put it in a place like a freezer. Okay, so we now call that change of state, going from a liquid to a solid, we call that solidifying. Solidifying. Okay, all right, and as you can see, all right, by cooling that even more, those will eventually become solid blocks of ice. Okay, so there you have it. Yeah, those are your 4 changes of state. First of all, we have melting, where a solid turns into a liquid. Okay, then we have a liquid turn into a gas, and we call that evaporation. Okay, then when we start to cool the matter and the gas condensates, it becomes a liquid, and we call that condensing. And finally, if we take a liquid, all right, and we cool it even more, all right, it will start to solidify and become a solid. Okay, right. As I said, you can go and conduct these experiments by yourself. I'm going to give you one last challenge now, and I'm not going to get you to answer this question because I know you all know the answer over there. Right? Is we now know that if we take the block of ice and we add heat to it, it's going to melt. Okay. What I want to know is, can you think of something that you've got in your own home that can actually speed up, right, this melting process? In other words, it can make this ice, this solid, melt even faster. Do you think you know the answer? Don't say it, right? Okay. So that's my challenge to you. See if you can think of something that you've got in, that I'm almost certain that you have in your house, all right, and that you can use, to melt this ice even quicker. And it's something that you've got in your kitchen, right? It's not a kettle, by the way, right? Something you use every day with your food, to see if you can make this solid, this ice, melt even faster. So that's my challenge to you, to go and find out and see if you can do that. All right. Hope you'll like the video. I hope it explains some things to you. I hope it can help you do your science work. And I hope that you will join us next time for another video. All right. See you later.
Bye, Mr. Van Straaten.
All right. Excellent. See you later.
Thanks so much.
Oh, I'm very glad. All right. Will you join me next time for my video?
Of course.
Excellent. Right. Okay. We'll see you then.
Okay, bye,
Right.
Mr. Van Straaten.
Bye.